All right, in this video, we're going to learn how to divide polynomials by monomials, which for my students is Module 9, Lesson 4. This is Florida's best benchmark, AR 1.4, which is divide a polynomial expression by a monomial expression with rational number coefficients. Remember, anytime you see that rational number, that means that word rational, it means it could be a fraction. So just a quick review of our quotient rule that we learned in a previous lesson or previous module. And that states that a to the power of m divided by a to the power of n, okay? So if we have something to a power of m and something to a power of n, what we're doing here with this quotient rule is we are subtracting those exponents m and n, okay? So if I have 9 divided by 3x, or 9 over 3x, here we're going to end up with 3 over x, because 9 divided by 3 is 3, and there is nothing to divide or apply that quotient rule to with the x. So that's just a review of how to simplify a fraction with an exponent or with a variable. In example B, we have 4a squared divided by 2a. So that is going to be equal to 2a, because 4 divided by 2 is 2. A squared divided by a is just a, because it's 2 minus 1. Okay, 6x to the power of 3, y squared, that's being divided by negative 2x squared, y squared. And that gives us negative 3x. Our y's here canceled out, and x to the power of 3 over x to the power of 2, 3 minus 2 becomes 1. 6 divided by negative 2 became negative 3. Finally, we have 9 over 15, and 9 over 15 will simplify to 3 over 5 because we can divide both of those coefficients by 3. A to the power of 5 over a to the power of 3, and I get a squared. B to the power of 3 over b to the power of 2, and I just get b. Now, if you still struggle with your exponent rules or dividing a monomial by a monomial, you need to go back to Module 7 for me and review your exponent properties. All right. So dividing a polynomial by a monomial. Okay, so our first step is going to be to divide each term in the numerator. Remember, the numerator is the top of the fraction, by the term in the denominator, the number in the bottom of the fraction. So I recommend separating these into different fractions so that we don't forget we are dividing every term. Step 2 is we're going to use the quotient rule. So if we have a variable that's being divided by a variable, we have to apply the quotient rule. Step 3 is to simplify each term. Okay, so if we had 2 over 4, that simplifies to 1/2. Special note that when we are dividing polynomials, the result may or may not be a polynomial. So polynomials, what that means is that polynomials are not closed under division. So when we were adding, subtracting, and multiplying polynomials, the result or the answer was always another polynomial. But when we are dividing polynomials, we will not always get a polynomial. So sometimes you're going to see a polynomial written like this, 12d squared minus 24d, with the division symbol, divide by 4d. Okay, so we're going to take this polynomial and divide it by this polynomial. So 12d squared divided by 4d. This is where we're separating it into different fractions. And then we have negative 24d divided by 4d. So now we have to simplify them. And we're going to use the quotient rule. So these are my numerators and these are my denominators. 12 divided by 4 gives me 3. D squared divided by d will give me just d. Negative 24 divided by 4, and I get a negative 6. D divided by d is just 0, or 1, sorry, not 0, but d divided by d would be 1, so I end up getting 3d minus 6. Is this a polynomial? Is this answer a polynomial? Absolutely, yes. Okay, remember, a polynomial cannot have a fraction or a variable in a fraction or a negative exponent. So here we have it written as a fraction, so we have a polynomial in our numerator and a monomial in our denominator. So we're going to take each one of these terms in our numerator and write it as a separate fraction over our denominator. So 2m squared over m plus 5m over m plus 1 over m. And all I did was use the same symbols that were here, okay? And I wrote it between the fractions. 2m squared divided by m, well, m squared divided by m, and I'm going to get m, so I end up with 2m. 5m divided by m, those m's will cancel out, so I just get 5. And then 1 divided by m, there is nothing that I can do with this m here in the denominator, so I end up with 1 over m. So when I put that all kind of back together, I end up with 2m plus 5 plus m to the negative 1 because that m was in the denominator, which means this is not a polynomial because my polynomials cannot have a negative exponent. Okay, so you could leave it like this, 2m plus 5 plus 1 over m, or you could simplify it out and write 2m plus 5 or m to the negative 1. But either way, you need to be able to represent that this is not a polynomial because I have an m or a variable in the denominator of a fraction. Okay, so in example C and D, again, we're going to take the 28a to the power of 3, divide that by 7a. We're going to take the 42a squared, divide that by negative 7a, and negative 14a, and divide that by negative 7a. So let's start to simplify our fractions. So 28 divided by negative 7 is negative 4. A to the power of 3 divided by a is a squared. 42 divided by negative 7 is negative 6, and a squared divided by a is a. Negative 14 divided by negative 7, I get a positive 2. Here, my a's will cancel out. So my final answer is negative 4a squared minus 6a plus 2. Is this a polynomial? Yes. I do not have a negative exponent, and I do not have a variable in the denominator of a fraction. Okay, finally, we have example D. And these are those rational coefficients that I was talking about, and that came from our benchmarks. So I understand that most students do not like fractions. It does not change what we're going to do here and how we are going to simplify this. So remember, when we are dividing by a fraction, we are multiplying by its reciprocal. And please forgive that positive 3, the animations are wrong here. So we're going to take this 2x to the power of 5 plus 4x cubed plus 3 halves x. And we're going to divide that by 1/2 x. But again, when we are dividing by a fraction, we are actually multiplying by its reciprocal. So 2x to the power of 5 divided by 1/2 x. Well, 2 divided by 1/2 is actually going to be 4 because 2 multiplied by 2 over 1 is equal to 4. So I end up getting 4x to the 4th. Well, where did I get this x to the 4th? Well, because I still had to treat the variables the same. X to the power of 5 divided by x is 5 minus 1, so that's x to the power of 4. 4 divided by 1/2, again, is 4 multiplied by 2 over 1, so that's going to be equal to 8. And x to the power of 3 divided by x, I subtract 3 from 1, or subtract 1 from 3, sorry, and I get 8x squared. And then 3 halves divided by 1/2, well, that's 3 halves multiplied by 2 over 1, which is equal to 6 over 2, which is equal to 3, so I get a positive 3. What I want you to know is that if you struggle with fractions and you forget that dividing by a fraction is the same as multiplying by its reciprocal, your backup choice, your backup option is to use a calculator. So if you type in 3ABC2, divide it by 1ABC2, it will give you the answer of 3. So use the tools at your disposal to help you get the right answer. This is your practice for Module 9, Lesson 4, or your dividing polynomials practice. So please make sure you complete this on paper and then complete it in Canvas.